meter, and there are 3 fillets, 2 at 2 ends and third fillet at the midpoint. Okay, the 2 end fillets have masses 79 kg. End fillet, but let us consider this is MA. End fillet MA is equal to 79 kg, and MC is equal to 40 kg, because it is end fillet. There are 2 fillets, 1, 2, 3, A, B, C. End fillet A and C, MC. Okay. Next is we have radius of rotation, that is RA is equal to 3 millimeter, and it is equal to 0.003 meter. Okay. Similarly, RC it is equal to 5 millimeter, and it is equal to 0.05 meter. So that we have already discussed, right? And if you go to the next slide, we have a radius of rotation is over. Then the middle fillet has a mass of 50 kg. MB is equal to 50 kg, and the corresponding radius of rotation is equal to what is the radius of rotation? It is 8 millimeter. That is 8 millimeter is equal to 0.08 meter. So that is the mass B. Next, and the corresponding radius. The pulleys are key to the shaft that the assembly is in static balance and the system is in statically balanced. The shaft rotates at 300 RPM. So that is the speed. It is equal to 300 RPM. By that you can find out omega, because omega you need to find out. Omega is 25 N by 60. And what is the answer for this one? I think 331.41, right? Correct? Are you sure?
Yes, sir.
Yeah. So this is what N, capital N. Next, what else is given? So the shaft is mounted on a bearing of 2 bearings, 2 meter apart. 2 meter apart. So X is equal to the distance between the bearing. So the distance between the bearing, I'll write it. Distance between the 2 bearings is equal to 2.4 meter apart. 2.4 meter apart. So next, what else is given? And it is having equal orang on each either side. So that we'll discuss while drawing the space diagram. Determine the relative angular positions of the fillet. That is the fillet A, B, C. There are 3 fillets. We need to find out theta A, angle of fillet A, and theta B. That is the first question. Okay. And theta C we need to find out. That is the second question. Dynamic reaction on bearings, that we need to find out. That I'll tell you what it is. Dynamic reactions. So that is the second question. Okay, I think all of you copied this given data. Let us go to the next step. Step 1. Step 1, space diagram. You know what is space diagram? Okay, so space diagram, we have a shaft. So I am going to draw the shaft. First we need to draw the reference line, you know that. So I'll draw the reference line. Okay, so this is my reference line, and on that I'm going to show the shaft. So the first thing you need to show the shaft. Okay, the shaft is mounted on a 2 bearings. First you need to draw the shaft. This is the shaft. Okay, so this is the shaft. And what is the length of the shaft? The length of the shaft is 3.6 meter. Right, 3.6 meter. The total length of the shaft is 3.6 meter. So I'll mention this distance as 3.6 3.6 meter. Okay, so the length is 3.6 meter. Is it visible? Okay, after that, on this shaft, there are three pulleys. Two pulleys on either side. Either side means extreme end. Are you following or not? On either side. Either side means on extreme end. So this is the first pulley. You know what is pulley? Pulleys are used to. What is the use of pulley? To use to transfer the power from one shaft to another shaft, connected by chain drive or belt drives. Correct? Connected by chain drives or rope drives. So this is a pulley. This is the pulley. We have a shaft here. If you want to transfer the power from one shaft to another shaft, we are going to use the pulleys. So this is the pulley, and it is used to transfer the power from one shaft to another shaft by means of a rope drive or belt drive, or you can use chain drives also. Okay, but the thing is, you need to use a pulley to change the speed. Here you can change the speed. The speed of the first pulley will be different. The speed of the second pulley will be different, right? But the power will be transferred from here to here. So that is the concept. Okay, so this pulley is the first pulley. We have A on one end, left extreme end. Let us consider this as A. C on other end. Okay, so this is C. B at the middle or the midpoint. Okay, this is B. This is about the pulleys. Okay, and after drawing the pulleys, we have two bearings. Two bearings are the shaft is mounted on two bearings, and the distance between the bearing is 2.4. 2.4, 3.6, 2.4. 3.4 is less than 3.6, so it will be somewhere here in between. But it is 2.4, and one more condition, you can take 2.4 somewhere here or anywhere. But you need to take this bearing in such a way that you need to have equal overhangs on either side. Equal overhang means 3.6 minus 2.4. The total remaining length is 1.2. Thus 1.2 will be divided equally, that is 0.6 meter on either side. 0.6 meter this side and 0.6 meter this side. So like that, you need to consider the bearing. Okay, bearing. I am going to consider the bearing now. Okay, so the bearing, I'll take the bearing somewhere here. Okay, so this is the bearing. This is the first bearing, and bearing is denoted by cross lines. This is indicating the bearing, and the second bearing is somewhere here. Okay, yeah, this is the second bearing. The first bearing will take it as L and the second bearing as M. Now, what is the distance between the bearing? The distance between the bearing is 2.4 centimeter. 2.4 meter, right? Yeah, it is meter. 2.4 meter. And if it is 2.4 at the center, we'll have two equal overhangs on either side. Here it is 0.6 meter. On other side also it is 0.6 meter. Total will be 3.6. You just check it. Total it 0.6 meter. 0.66 that is 1.2, 1.2 plus 2.4, so 3.6. The total will be 3.6. All of you copied? Hello? Am I audible?
Yes, sir.
Yes, sir.
Okay, all of you copied this? Now
Yes.
we need to draw the front view, okay? Front view. Mark a point. Okay, to draw the front view, you need to consider any plane, any one plane as a reference plane to measure the angle, right? Here there are two types of reference plane. One is to identify the reference plane to take the angle in the space diagram. Second one, to find out the couple also, we need to find out one more reference plane. There are two types, don't get confused. Both are different. Okay. One is at the space diagram at the beginning. The second one to find out the couple in the tabular column. Okay, that is different. Both are not same. Please remember, you'll get confused. Okay, the student, those who have backlog in the last few years, uh, at the time of the backlog exam, they'll call and, sir, why the reference plane is different in both the case? So you have taken reference plane as A in space diagram and B in tabular column. Why it is different, sir? It is same, no? So don't get confused. A reference plane, the first for the space diagram, the reference plane is different. Okay, on the basis of the given data, you're going to consider the reference plane for the space diagram. But in the tabular column, you're going to consider the distance from reference plane. That reference plane, it is your duty to identify. But here it is according to the given problem, space diagram. Okay, tabular column, you decide which plane to be selected as a reference plane to find out the couple. Please remember. Okay, here we have three masses A, B, C. Which one you gonna select as a reference plane? The reference mass, it is not reference plane, it is reference mass. Okay, reference mass is different, reference plane is different. Here reference mass. Okay, which plane you to select it? Here, is there any angle given in the problem? There is no angle given in the problem. Not even a single angle is not given in the problem, right? Not even a single angle is given in the problem. You can take A as a reference mass, B as a reference mass, or C as a reference mass. It's left to you because the angle is not given in the problem. If any one angle is given, you could have taken a particular plane. So if in the problem, if the angle of B is 90 degree with respect to A, then you must take A as a reference plane because this 90 degrees measured from A. Angle of B is 90 degree with respect to A. That's why you should take A as a reference plane. But here there is no such sentence or data given in the problem. That's why either you can take A as a reference mass, B as a reference mass, or D as a reference mass. Please select A or B or C as reference mass. Okay, so I will select A as a reference mass. Okay, so I'll take A as a reference mass. So this is MA. Right now it is at 0 degree. It is at 0 degree. Okay, MA. MB, I don't know the angle. MB, I don't know the angle. I'll show it somewhere here. Okay, anywhere you can show, no problem. Anywhere you can show MB. I don't know the angle. let us take this as theta b with respect to a. Okay, with respect to a. MC is also unknown. You can take somewhere here. You can take somewhere here. Okay, I will take it here. That is MC, and the corresponding angle of C is theta C. Theta C, and you can show it in the dotted line. Why dotted line? Because we don't know the angle. That's why it is dotted line. So I'll show it in the dotted line. But I know the mass, right? I know the mass, so no need to shade it. Only the line is dotted because the angle is unknown. That's all, the space diagram. Now tell me, what is the angle of A? Angle of A, according to the space diagram, it is 0 degree. We have considered as 0 degree. But it is not given in the problem. You need to assume it as 0 degree. This point is very, very important. All of you copied? Please, can anyone answer?
Yes.
Copied?
Yes.
Yes, very good. Okay, let us proceed. Step 2, table or tabular column. How many masses are there? You forget about the bearings, okay? We have only 3 masses, A, B, C. So, and it is statically balanced. Write down, there are 3 masses. 3 masses, nothing but full-less. 3 full-less. Okay, 3 full-less, and they are statically balanced. Statically balanced. What do you mean by this? Why I'm writing this sentence? Because it is given in the problem itself. Statically balanced. That indicates summation of all the force must be equal to 0. That is, force polygon must be closed. Force polygon must be closed. See, 50% of the solution is here. Force polygon must be closed. That indicates you need to find out the centrifugal force. Centrifugal force due to this mass. So the table, I'm going to draw the table. How many columns you need to take table? One is plane, second one for mass, third one for radius of rotation, fourth one for centrifugal force. That's all. Okay. Centrifugal force. The first one, heading, there are 3 masses, 1, 2, last one is 3. Here we need to consider plane, mass, m in kg. So here it is a radius of rotation. It is r in meter. This is centrifugal force divided by omega square. Here omega square is common. We know the value of omega square, but it is common for all. You just divide it, that's all. Kg meter. Omega is common for all. You can multiply it, no problem, not an issue, but it is not necessary because it is a common factor for all the masses, right? A, B, C. Mass of A. What is the mass of A? Mass of A is 79 kg. What is B? Mass of B? Mass of B is 50 kg. Mass of C is 40 kg. Now, what is the value of radius? Radius, the first one is, I think it is 0.003, 0.005. B 0.008. 10 minutes ಇದೆ ಬೇಗ ಫೋರ್ಸ್ ಪಾಲಿಗಾನ್ ಡ್ರಾ ಮಾಡಿ ಹೋಗುವ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಮಾಡು centrifugal force by omega square you need to divide multiply this one, right? Okay, what is the value of the first answer or the first column?
0.237.
0.237. Second one, 0.4. Next, and
0.2.
just a minute. ಎಷ್ಟು ಬರುತ್ತೆ?
0.2.
0.2 ಬರುತ್ತಲ್ಲ. ಓಕೆ, please copy this. Okay. After this, you need to draw the force polygon because we need to find out the first question. What is the first question? Question number 1 is you need to find out the value of theta B, theta C. Theta A is 0 degree. Forget it. Theta B and theta C. To find out that, go to the force polygon. Step 3, force polygon. Here there is no matter of couple we'll see later, okay? Couple polygon, force polygon. So force polygon, you need to take a proper scale. Here the maximum value is 0.4. And what scale you are going to consider? Hello? Point 1 is equal to 1 centimeter.
0.2.
0.2 is equal to 1 centimeter.
No, 0.1.
0.1 is equal to centimeter.
0.1 1 kg meter is equal to 2 centimeter.
Yes.
Okay, it's up to you. 0.1 kg meter is equal to 2 centimeter. Okay, first one we need to mark the point. This is the point O. Okay, A is 0. Angle is 0. Look at this. A is 0 angle. But what is the length? 0.237 ಇದೆ. ಕನ್ವರ್ಟ್ ಮಾಡಿ ಸ್ಕೇಲಿಗೆ ಎಷ್ಟು ಬರುತ್ತಾ? ಇಂಟು 2 ಮಾಡಿ.
4.74.
4.74. 0 degree angle, 4.74. 237 0 degree. So this is the reference line. A ಅಲ್ಲ? Next B. B is 0.4, but I don't know the length. 0.4 into 2. ಎಷ್ಟು ಬರುತ್ತೆ ಆನ್ಸರ್? ಇದು ಲೆಂತ್ ನೋಡಿ 2 centimeter
8.
divided by 0.1 into 0.237 ಎಷ್ಟು ಅಂತಲ್ವಾ ಆನ್ಸರ್? ಎಷ್ಟು ಬಂತು ನಿಮ್ದು? 6 ಪಾಯಿಂಟ್. ಇದು ಎಷ್ಟು ಬಂತು?
4.74.
ಫಸ್ಟ್ ಒನ್
The first one.
4.74. 4.74. ಇದು ಸೆಕೆಂಡ್ ಒನ್ ಎಷ್ಟು ಬಂತು ನೋಡಿ? 2 centimeter divided by 0.1 into 0.4. 8 ಬರುತ್ತಾ? 8 centimeter. ಥರ್ಡ್ ಒನ್ ಎಷ್ಟು ಬಂತು ನೋಡಿ? 4 centimeter ಬರುತ್ತಂತ. 2 by 0.1 into 0.2. 4 ಬರುತ್ತಲ್ಲ? ಮಾಡಿದ್ದು ನೋಡಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಅದೆಲ್ಲ ಹಾಗೆ ಮಾಡ್ಕೊಳ್ಬೇಕು. ಓಕೆ, ಸೆಕೆಂಡ್ ಒನ್, I don't know the angle, but I know the length. Length is 8 centimeter. Take the compass, take 8 centimeter and cut the length 8 centimeter from this point. Okay, 8 centimeter, cut the length. Similarly, third one is 4 centimeter. Take 4 centimeter from this point, cut the length. We'll get a point here because we don't know the angle, we know the length, right? Now we can join okay, so this is what 0.4. This is what 0.2. Now we can measure the angle. This angle is theta B, and if you draw the reference line through this point is actually B, right? B, and the corresponding angle will be theta C. Theta C. Now tell me the answer for theta B and theta C.
Theta B 157. 157.
187.
157.
158.
157.
Okay, 157, 158. Okay, 154 is the right answer. You just check it. Okay. Next, theta C. Theta.
312.
Yeah. Answer?
312.
312. Okay, very good. 312 is okay, no problem. But actual angle is 306. Okay. Okay, this is the first condition. Okay, for the condition 1, we need to find out theta B and theta C. Okay, it's almost 11 o'clock. You can join the next class. Okay, but I'll continue. Okay, I have to record the recording is on. I'll finish the problem. Okay, you can leave the meeting, no problem. Just finish the finish till here and leave the meeting. I have to continue the, no, you just leave it. Okay, I have taken attendance, no problem. Please leave the meeting. Okay. The next step 4. Step 4. Okay. Tabular column including bearing. So that is the next step, because we need to find out the reaction force in a bearing. Okay. So you can leave the meeting, not an issue. Okay, I'll repeat it in the next class, no problem. Okay, so this is the tabular column including bearing. Now I'm going to consider the bearing also. Here we have considered bearing as the figure L and M. L lies between A to B and M lies between B to C. So we need to consider 5 elements. 3 is bearing, 3 is pulley and 2 bearing. Okay, so that's why I'll take a tabular column with five rows. 5 rows because including 2 bearings. 1, 2, 4, 5. So how many columns? 6 columns, because we have taken a reaction force and all the forces are rotating in a different planes. Dynamic balance or dynamic force we need to find out. Dynamic force means we need to consider the couple. So the first one is a plane. Second one, mass M in kg, radius R in meter, centrifugal force by omega square kg meter. Next is the distance from a reference plane. It is meter. Last column is couple by omega square kg meter square. Plane, let us take the first plane as A. Second one, you just see the space diagram L. Please consider it as L, including bearing, right? Including bearing, L. Next is B. Next M. Last one is C. Please see write it in the same order: A, L, B, M, C. Okay. The next thing, the masses. Masses are first one 79. Same thing we need to find out. 79. Second one, you take it as L. L, unknown. Okay. Third one, it is 50. It seems, yeah, 50. The fourth one is M. Let us take M. Mass of the bearing M. Next, last one is 40. Yeah, 40. Next, radius of rotation of A is 0.003. here you take it as RL because it is unknown. Because it is unknown. And 0.008. Next, this is RM. Last one 0.005. Okay, 0.005. So RL and RM is unknown. ML and MM is also unknown. You just leave it. Next, the centrifugal force, if you multiply this, we'll get 0.237, it seems. 237. Okay. Here it is ML, RL. The third one, 0.4. Here MM, RM. Last one is 0.2. 0.2. Very simple, right? Okay. Next, we need to check, is it possible to find out the value of ML, RL and MM, RM by the centrifugal force polygon? It is not possible because we have two unknowns. We have two unknowns. Two unknown, both in magnitude as well as direction. So you cannot draw the force polygon. So two unknowns. Therefore, can't draw force polygon. Is it possible to draw the force polygon? No, it is not possible because there are two unknowns. Next, go to couple polygon. To draw the couple polygon, you need to consider the reference plane, the distance from the reference plane. Which plane you're going to select as a reference plane? See, we have two unknowns. One is this and the second one is this. Either you can consider L or M as a reference plane because you cannot consider A, B, C because we have known values. So if you consider any one plane out of A, B, C, that term will become 0, then the problem will be complicated. So try to make unknown value into 0. Either you can consider L as a reference plane or M as a reference plane. So it's left to you. I will select which plane as a reference plane? Okay, I'll select L as a reference plane. L as a reference plane. L as a reference plane. Okay, so go to the previous figure. Yeah, L as a reference plane. So this is L, RP. RP, why it is RP? Because we have unknown mass. This is positive. This is negative. So this is the indication. Now we can take the distance from the reference plane. First plane is A to a reference plane, A to L is 0.6 meter. So write down 0.6 meter. Next, what next? L to L, 0. L to B. Yeah, L to B distance. Look at this. L to B distance. There is a complication here. You need to measure the distance, proper distance. L to B, I think it is 2.4. 2.4 divided by 2. 2.4 divided by 2 means 1.2, right? This is 1.2 and this is also 1.2. So 1.2. 1.2. 1.2 distance. Next is L to M, distance between L to M. L to M is 2.4. 2.4. Next is L to C. L to C, 2.4 plus 6, 3 meter. 3. meter. So this is the concept. Next is we need to find out the couple. Couple, very simple. You can easily find out the couple. Multiply this with this. We'll get answer for couple. So 6 into. We'll get the answer. Okay. The first value, I think it is negative, right? Because it is in the opposite direction, negative direction. So this is negative, A to L, negative, minus. So the answer will be minus 0.1422 answer. Here it is 0, this with this multiplied. And here we'll get answer as 0.48. And here we'll get the answer 2.4 into RM. The last answer is 0.6. This is what your couple. Now we can draw the couple polygon because we have all unknowns. One is unknown, all knowns and one unknown. You can go to the couple polygon. Step 3. Step 5, Allah? Yeah, step 5, couple polygon. Couple polygon. You need to take the proper scale. See the table. The maximum value is 0.6. 0.6. It's better to take 0.1 millimeter, 0.1 kg meter square is equal to 0.1 kg meter square is equal to 0.1 kg meter square is equal to 1 centimeter. That is the scale. Okay. Yeah. So I am going to consider the scale 0.1 kg meter square is equal to 1 centimeter. 1 centimeter. So here we have the first point, the very first point. The first point is actually the starting point. The first mass or the reference mass is A. Let us consider A, starting point. A. Starting point A. So let us mark somewhere here 0, O. And that the reference line, 0 degree line. Yeah, this is 0 degree line. Next is length is 0.1422. 1422 because 0.1 is equal to 0.1 centimeter, 1 kg meter square is equal to 1 centimeter into 0.1422. What is the answer? That we need to find out. So I'll check it. 1 by 0.1 into 0.1422. That will be the answer is 1.422 centimeter. 1.422 centimeter, but it is negative, minus, right? You take it in negative direction, it is 1.42, it is 1.5 centimeter nearly. Okay, negative. Okay, so this is what 1 point, that is point minus 0.1422 minus 0.1422. Okay, after that the reference line is already there. Next is 0, you forget it. Next 0.48. Find out the value of 0.48 in centimeter. So 0.48 will get 4.8 centimeter, right? 4.8 centimeter. But what is the angle of B? Angle of B, we have found angle of B is 154 degrees. Take 154 degrees. 154 degrees. So I will take 154 degrees with a length of 4.8. 4.8. 154. Yeah, 4.8. This is 4.48, and the angle is theta B. It is equal to 154 degree. 154 degrees. Next, once you get the point A, we need to take the reference line. Yeah, this is 0 degree line. Next is unknown. You just forget it. Go to the next step. That 0.6 into 0.1 divided by 2 centimeter. That will gives you 6 centimeter. 6 centimeter. Angle of C is 306. Angle of C is 306 degrees. You take 306 degrees. 306 degrees. Okay, 306 degrees somewhere here. Theta C. Okay, 306 degree. What is the length? Length is 6 centimeter. 0.6 sala 6 centimeter. So mark a point here. This is a 6 centimeter. Yeah, 6 centimeter. Now mark or draw the reference line. This is A, this is B. B. So the last side is remaining, that is 2.4 into RM. So the last point, if it is a closed polygon, the last line itself is a unknown. That is unknown, and just show it in dotted line. And this line indicates what is that? 2.4 into RM. 2.4 into RM. And the corresponding angle, this is theta M. Theta M. The corresponding angle is theta M. This is theta M. Okay, calculation. I'll do it in the next slide. Calculation. Theta M is equal to what answer you're getting. You just measure it. Here I'm getting theta M is equal to, I'm getting the angle theta M. Just a minute, I'll show you the angle theta M. Okay, theta M, I'm getting 51 degree. Theta M is equal to 51 degree. And length of OB, length of OB is into scale is equal to 2.4 into RM. That is the length. So RM, I'm having the length is equal to, what will be the length? I think if I measure the length, I'm getting around 4.8 4.8. So 4.8. Okay, 4.8 I'm getting. So I'll write the same thing. So the 4.8 into scale. What is the scale here? Scale we have taken 1 centimeter is equal to 0.1 into 4.8 centimeter is equal to what? That is the scale. Here 2.4 into rm. So therefore rm is equal to, you take it because both are unknown, rm is equal to, we'll get the answer 4.8 into 0.1 divided by 2.4. The answer is correct or not, I don't know. Yeah, the answer is correct. We'll get 0.2. I don't know, you check your answer, okay? This is kg meter. Now, what is the dynamic reaction in M bearing is equal to m mass into omega square into rm. This is the dynamic reaction or dynamic force. So it is equal to, you know, the value of mmrm. So mmrm into omega square, it is equal to, mmrm is 0.2 into omega square is 30.4, right? Check your 31.41. 31.41. Answer is into 31.41 will get 0.2 into 31.41. 41 square, right? 31.41 square will get 197.31 Newton. This is the dynamic force acting on bearing M. Similarly, the next one is step 6, force polygon. There you can find out the reaction at L. Force polygon, because we know the value of mmrm, this value we know, that is 0.2. Now we can find out the value of mlrl by drawing force polygon. Force polygon, you take the proper scale, you can take same scale 0.1 kg meter is equal to 1 centimeter. You can take the same scale. Okay, the first starting point, this is the starting point O. Next is okay. The length is 0.237 is there. 2.37 will come. 2.37. 2.37 0 degree. Okay, so this is the first one. Next is A, reference line. Next mass is B, you just forget it as L. Next 4.4 into 0.1, it is 4 centimeter. Angle of B is, check it, angle of B is 154 degree. Take 154 degree, 4 centimeter, right? Yeah, 4 centimeter. 154, 4 centimeter. So This is actually 0.237. This is actually 0.4. The corresponding angle is theta B, 154 degrees. Next, the reference line. Next, theta. What is the next? Next one is MMRM. MMRM we are getting 0.2, right? This is 0.2. What is the angle? 0.2 angle 51 degree. Take 51 degree. 0.2 means 2 centimeter. 51 theta m. Two centimeter. This is the point. Next, you just draw the reference line. This point is A, this point is B, this is C. After that, again we have next mass is 0.2, 2 centimeter, but the angle of C is 306. 306, 2 centimeter, 306. So I'll mention it in the red colored line, 306. So theta C is 306 degrees, and so it will come somewhere here. Just a minute. Yeah, 306. 306 somewhere here. But the length is also 2 centimeter, same. This here. And draw the reference line. Okay, last one. And one more, it is not completely closed, right? Because this is 2.2. This is 0.4. Again, this is 0.2. Next is, to close it, you need to join the line with a dotted line. And this line indicates it is, what is that table? We have MLRL. MLRL. And the corresponding angle is theta L. Okay, measure the angle of theta L. I am getting the theta angle, theta L. I'm getting it's around 235 degrees. Check the angle, and the length of this is C, this is D, right? The point D, correct? OD into scale is equal to MLRL. So length of OD I'm getting around 2.5 centimeter. You check your length, may not be getting the same. Scale is 1 centimeter is equal to 0.1 into 2.5 centimeter is equal to MLRL. If you calculate, we'll get the answer for MLRL is equal to 2.5 into 1, that is 2.5, 0.25 kg meter, MLRL. Therefore, reaction at pairing L is equal to ML square omega square RL square. It is equal to M square ML into omega square into RL. So this is RL into omega square. It is equal to MLRL is nothing but 0.25 into omega square is 31.41 square. We'll get the answer. 0.25 into 31.41. 1.41. So we'll get answer as dynamic force is equal to dynamic force reaction is equal to 246.647 Newton. This is the dynamic force acting on bearing L. Bearing L. This is how to find out the reaction force or dynamic reactions at two different bearings. So you need to consider the bearing or the reaction force. If you want to find out the force, you need to have the centrifugal force is equal to, the formula is m omega square into r. So you take this as unknown quantity, that is m into r. Omega square is already given in the problem. You find out the value of mr by considering it in tabular column. So ml rl, mm rm. So find out those two values, ml rl and mm rm, and the corresponding angle. Angle is not necessary actually, but it's better to measure because we need to take that in a next polygon. So find out those things and find out the value of dynamic reactions. So this is the end of the problem. Thank you.